everyone, and welcome to this grade 9 mathematics lesson where we will be exploring factorization. My name is Miss Donnell Phillips. Let's get started. Now, what exactly is factorization? Throughout mathematics, we will often use factorization in many different situations. Factorization is used to simplify expressions, or factorization writes a number as the product of smaller numbers. Example, 24. If we were to list the factors of 24, we would have 24 and 1, 12 and 2, 8 and 3, and 6 and 4. Now remember, when we speak of factors, we are referring to its divisors. So as long as we have a number and we have some smaller numbers that could divide this big number directly without leaving any remainders, then that small number is considered a factor of the bigger number. So again, the factors of 24 are 24 and 1, 12 and 2, 8 and 3, and 6 and 4. So before we actually start factorization, it is important that we know how to find the highest common factors in algebra. So the highest common factor, or HCF, is found by finding all common factors of two numbers and selecting the largest one. So here we have 8 and 12. We want to find the highest common factor of 8 and 12. So the first thing we have to do is to list all the factors of 8 and all the factors of 12. So the factors of 8 are 1 and 8, 2 and 4, and the factors of 12 are 1, 12, 2, 6, 3, and 4. So we have them listed there. The next step in determining the highest common factor is to look for the largest number that is found in the two sets. So the first thing we do is we identify those that are common, and the common ones are 1, 2, and 4. That means that the largest one is 4. So we can conclude that the highest common factor of 8 and 12 is 4. Highest common factor in algebra. Now, finding the highest common factor with numbers is pretty much similar to finding highest common factors in algebra. If we're given any two algebraic terms, we need to follow the same steps to be able to identify the highest common factor. So consider the following. 12a squared b and 6a cubed b squared c. Now, to find the highest common factor of these two terms, the first thing we have to do is to compare the coefficients and then compare the variables separately. So let's look at the coefficients. The two coefficients that we have are 12 and 6. If we were to identify the highest common factor of 12 and 6, we would see that the highest common factor of these two coefficients is 6. The next step states, when comparing symbols with powers, we select the highest power of the symbols, which is common to both expressions. So let's look at the a's. In the first term, we have a square, and in the second term, we have a cube. We can't select a cube because a cube can't be found in the first expression, which is a square. So we have to select a square. Similarly, the first term has b and the second term has b squared. We would have to select b because b squared is not found in the first term. And lastly, the first term does not have a c, but the second term has a c. Because there is no c in the first term, we can't include the c in the highest common factor. So, from the top, we have the highest common factor of 12 and 6 being 6. Then the highest common factor of a square and a cube being a square. And the highest common factor of b and b squared is b. And we can't include the c because there is no c in the first term. So, the highest common factor of these two terms, 12a squared b and 6a cubed b squared c, is 6a squared b. Now, there are many types of factorizations. The ones that we are going to be focusing on would be Factorization using common factors. Factorization by grouping. Factorization by using the difference of two squares. Factorization of expressions that can be expressed as perfect squares. And lastly, factorization of quadratic expressions. Now in this lesson, we are going to be focusing on the first three types of factorization. And in a later lesson, we're going to explore the last two types. So we're going to start with factorization using common factors. Factorization using common factors. We can use the distributive law to insert brackets in an algebraic expression. Now the reversal of this process is called factorization. So we have three examples that we're going to go through. The first one, 7x plus 7y, 9b squared subtract 3b, 6m to the power of 5, n to the third power p, plus 8m to the power of 4, n to the power of 2, p to the power of 2. So we're going to use common factors to factor these three examples. So the first example that we're going to look at is 7x plus 7y. And because we're using factorization using common factor, the first thing we need to do is identify the common factors between both terms. So this first term we have 7x and this second term we have 7y. Now we can see that both terms have 7s in them. So that means that the common factor between 7x and 7y is 7. So we write that outside and we open bracket. Now 7x divided by 7 would be 1x, but in mathematics it is understood that whenever we see x standing by itself, that there is actually a 1 in front of it. So we don't need to write 1x. We could just write x. There is an addition sign, so we write it back. 7y divided by 7 is just y. And we close bracket. Now we can check to see if when we clear the bracket, if we would get back what we started with. So we would need to multiply 7 by x and then add that to 7 by y. So 7 times x would give us 7x plus 7 times y, 7y. So when we factorize 7x plus 7y using the common factor method, we get 7 into x plus y. The next example, 9b squared minus 3b. So we're going to look at the two coefficients. We have 9 and we have 3. What is the highest common factor of 9 and 3? The highest common factor of 9 and 3 is 3. So we put that outside. Can we close the bracket? No, we shouldn't, because both of the terms have b's in them. So we know we have to look at b squared and b. The highest common factor of b squared and b would be b. So outside of the bracket, we have 3b. So we're going to close the bracket now. So 9 divided by 3 gives us 3. And b squared divided by b gives us b. Put back our subtraction sign. 3 divided by 3 is 1, and b divided by b would also be 1. So this would just be 1. And in actuality, we know that when we multiply 3b times 1, anything that multiplies by 1 would give us back what we started with. So 3b times 1 would give us 3b, and 3 times 3 is 9, b times b is b squared. So even if we clear the bracket, we would get back what we've started with. So this one is also correct. And the last one, 6m to the power of 5, n to the power of 3, p plus 8m to the power of 4, n to the power of 2, p squared. This one is a little longer than the first two. So the first thing we're going to look at is the coefficients. So we have 6 and 8. The highest common factor of 6 and 8 is 2. So the 2 goes there. Now we're going to look at the m's. We have m to the power of 5 and m to the power of 4. So we're going to select m to the power of 4. Focusing on the n's now, we have n to the power of 3, n to the power of 2. That means that the HCF of these two would be n to the power of 2. And lastly, we have p and p to the power of 2. So the HCF of p and p squared would just be p. So this is what we have that's going to be outside of the bracket. We can open bracket now. 6 divided by 2 gives us 3. So let me just show you m to the power of 5 divided by m to the power of 4. We know that m to the power of 5 is m multiplying by itself 5 times. And m to the power of 4 is m multiplying by itself 4 times. If we were to cancel m with m, m with m, m with m, m with m, we would just have 1 m remaining. It would actually be m over 1, right? But we know that anything written with a denominator of 1 is just the number itself. In this case, it's going to be the letter itself. So m to the power of 5 divided by m to the power of 4 would just be m. Now n to the power of 3 divided by n to the power of 2, same concept. We have 3 m's, 3 n's, n, 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 all over 2 n's, n, n. When we cancel, we have 1 n remaining. So this would just be n. And now we focus on the p. P divided by p would just be 1. So we don't write it back. We just leave it as it is. So this first term is finished. Now we move on to the second term. 8 divided by 2 is 4. M to the power of 4 divided by m to the power of 4 would be 1. We don't write that. N squared divided by n squared is 1 also. We don't write that. And p squared divided by p would just be p. So when we factorize 6m to the power of 5, n to the third power and p, plus 8m to the fourth power, n to the second power and p to the second power, we get 2m to the fourth power n square p into 3mn plus 4p. Now you can clear the bracket, you can multiply what's outside by what's inside, and you will see that we're going to get back what we started with. Factorization by grouping. Now factorization by grouping means that we need to group terms with common factors before factoring. We have 3 examples again that we're going to be exploring. The first, 6x plus 9 plus 2kx plus 3k, 5p plus 10q minus np minus 2nq, and m squared minus 2m minus 2n plus 2n. First example, in factorization by grouping, we have 6x plus 9 plus 2kx plus 3k. Now the first thing we have to do is to decide which pairs are we going to group. We see that some of the terms have x's and some of the terms have k's. So we could group 6x with 9, and then we could group 2kx with 3k. Let's see how it goes. So since we've grouped these, we're going to factorize this set first, 6x plus 9, and then we're going to factorize 2kx plus 3k. So 6x plus 9, looking at the coefficient, we have 6 and 9. When we find the highest common factor of 6 and 9, that is 3. The 9 doesn't have an x, so we can't include the x outside of the bracket. So we're going to open bracket now. 6x divided by 3, or 6 divided by 3 is 2. And because there is no x, we just have to rewrite the x that's up there. Put back our addition sign. 9 divided by 3 is 3. So when we factorize this first pair that we have grouped, we have 3 into 2x plus 3. Now we're going to factorize the second pair, which is 2kx plus 3k. Now the first, looking at the coefficient, we have 2 and we have 3. 2 and 3, we can't find any highest common factor for them, so we move to the variables. The first one has kx and the second one has k. So we can see that k is common in both. Write the k outside, open bracket. 2kx divided by k would just be 2x plus 3k divided by k would be 3. And at this point, you're supposed to recognize that both brackets have the same algebraic expression in them. So what we do, we write what's in the bracket first. We have 2x plus 3. And in another bracket, we write the two terms that are outside of the bracket. So in this case, this is going to be 3, and this is a positive k, so we put plus k. So when we factorize 6x plus 9 plus 2kx plus 3k, we get 2x plus 3 into 3 plus k. The second example, 5p plus 10q minus np minus 2nq. We're looking at them. We could start by grouping this first pair, 5p and 10q, and then we're going to group this second pair. Right? So 5p, 10q, look at the coefficient. 5 and 10, the highest common factor of 5 and 10 is 5. Put that outside. 5p divided by 5 is just p. 10q divided by 5 would be 10 divided by 5 is 2, and we write back the q. Next, we look at np minus 2nq, and we realize that there is the n that is common, so we write the n outside, open bracket. np divided by n would just be p, and 2nq divided by n would be 2q. Now we have to pay attention to the signs that we're working with. In this case, we have a minus p outside, a minus n outside. And we have to get, if we just rewrite the minus 2 down here, when we go to clear the bracket, minus times a minus will give us a positive. And we don't have a positive there, we have a negative. So we have to write this as a positive. So we know that minus n times a positive 2q would give us a negative 2nq. So we close there. Looking at the two brackets, both of them have the same thing. P plus 2q in the first bracket, and in the second bracket, 5 minus n. So this is the solution for the second one. And the final example, m squared minus 2m minus mn plus 2n. Looking at the first pair, we're going to group these two and work them first. So we have m squared and m. We have m squared and 2m. M is common, put that outside. Open bracket. M squared divided by m would just be m. And 2m divided by m would be 2 because it's a subtraction sign. We have to write that back. Second pair, we have mn plus 2n. So we're going to take out, we're going to rewrite the subtraction sign, and we have n being common in both terms. Mn divided by n would be m, and 2n divided by n would be 2. Now let's pay attention to this so that you could see how we moved from an addition sign to a subtraction sign. Now if we go to clear the bracket, we have minus n into m take 2. Now minus n multiplied by m would give us minus mn, and minus n multiplied by minus 2 would give us positive 2n. If we had put an addition sign there, then that would have changed the entire sum. So we need to be careful with our signs. Both brackets have the same thing, so we're clear. M minus 2, and in the second bracket, put the stuff that is outside. This would be m take n. And this is a factorization for m squared minus 2m minus mn plus 2n. Factorization using the difference of two squares. Now the difference of two squares is where one perfect square is subtracted from another. It arises when a minus b and a plus b are multiplied together. Once we recognize its form, the difference of two squares is easily factored. We have x squared minus 36 as the first example, 144 minus 25y squared, and a minus b all squared subtract 16. So the first example for factorization using the difference of two squares, we have x squared minus 36. Now the first step requires us to write both terms as a squared number. So we already have this as x squared. This is good. Now we have to write 36 as a squared number, and we know that the square root of 36 is 6, so this would just be 6 squared. Because both terms are squared, we could write them in bracket x minus 6 all squared. And then when we expand this, we would have x minus 6 in the first bracket and x plus 6 in the second bracket. Now I am going to show you that when we expand it, we're going to get back what we started with. So we have to multiply first term in the first bracket by the first term in the second bracket, and then first by last. Then we're going to do last by first and last by last. So x times x gives us x squared. X times 6 gives us 6x. Minus 6 times x gives us minus 6x. And minus 6 times 6 gives us minus 36. Now we have a positive 6x and a negative 6x. These two can be cancelled out, so we're left with x squared minus 36. So this is just to show you that whenever we expand, we should get back what we started with. If when you expand you realize that you didn't get what we started with, then you probably made a mistake somewhere and you should recheck it. All right, so the second example, 144 minus 25y squared. So 144 written as a square number, the root of 144 is 12. So this is 12 squared minus 25 written as a square number is 5. So we have 12 squared minus 5y squared. So we can write this 12 minus 5y all square, and then we expand it. So this would be 12 minus 5y in the first bracket and 12 plus 5y in the second bracket. Now you need to be careful with the signs in the first and the second bracket. In the first bracket, the sign is always a subtraction sign. See, subtraction and subtraction. And in the second bracket, it's always an addition. That is the only way that when you multiply, you're going to get back what you started with. You can try multiplying. You can try putting subtraction sign in both brackets and multiplying them and see what you're going to get. So 144 minus 25y squared, when we expand it, or when we factorize it using the difference of two square, we get 12 minus 5y and 12 plus 5y. The last example, we have a minus b all square minus 16. This is already written as a squared term. We have a minus b all square. So we're going to write this 16 as a squared number. The root of 16 is 4, so this would be 4 square. Now we put everything in bracket. We have a minus b minus 4 all square. So when we separate them into the two brackets, the first bracket is going to get all subtraction signs, a minus b minus 4. And the second bracket is going to have a minus b, but instead of writing a subtraction sign, we now have to turn this into an addition sign. So when we factorize a minus b all square minus 16 using the difference of two squares, we get a minus b minus 4 multiplied by a minus b plus 4. So for your homework, you're going to try the following. The first one, 36a squared minus 169x squared. Number 2, 2x cubed minus 3x squared minus 6x plus 9. The third one, 2a into c plus d minus c plus d. And lastly, pq squared minus p squared q. So to summarize today's lesson, factorization writes a number as the product of smaller numbers. The highest common factor, or HCF, is found by finding all common factors of two numbers and selecting the largest one. To find the HCF of algebraic terms, we must compare the coefficients, then compare the variables separately. And finally, the types of factorizations include factorization using common factors, factorization by grouping, and factorization by using the difference of two squares. I do hope that I was able to shed some light on this grade 9 mathematics lesson where we explored factorization. Join me again next time. My name is Miss Donnell Phillips. Goodbye.